On rooftops and across vast open fields, they sit perfectly still and silent, yet they are quietly performing something close to magic, turning sunlight directly into electricity. No moving parts, no fuel, no noise, no smoke. Just light going in and power coming out. But how on earth does a flat sheet of glass and silicon make electricity out of nothing but sunshine? It all starts with the sunlight itself. Although it feels like a smooth, steady glow, sunlight is actually made of countless tiny packets of energy called photons. Every second, an unimaginable number of these little energy bundles pour out of the sun, race across space, and rain down onto everything below, including the surface of a solar panel. Now for the panel. A solar cell is made mostly from silicon, the same material found in sand and computer chips. Silicon is a special kind of material called a semiconductor. In a solar cell, it's formed into two thin layers, each treated with a tiny amount of other elements so that one layer has spare electrons to give, and the other has room to take them. Where those two layers meet, something invisible but crucial forms. A permanent, built-in electric field, a one-way push baked right into the cell. Think of it as a tiny, silent pump sitting at the boundary, always ready to shove any loose electron in one single direction. On its own, it does nothing, but the moment sunlight arrives, it springs into action. Here's the heart of it. When a photon of sunlight strikes the silicon, it transfers its energy to an electron and knocks it completely free from its atom. Suddenly, that electron is loose, able to move around inside the silicon. This is the famous photovoltaic effect. Light, quite literally, shaking electrons free. Multiply it by trillions of photons, and you have a whole sea of liberated electrons. And this is where that built-in electric field earns its keep. The instant those electrons are freed, the field sweeps them all in the same direction, herding them toward one side of the cell. Instead of drifting about randomly, the electrons are forced to flow together in an organized stream. And a steady, organized flow of electrons is exactly what we call an electric current. To capture that current, the cell is laced with a fine grid of thin metal lines printed across its surface. These act like gutters collecting rain, gathering up the flowing electrons and channeling them into wires. Connect those wires to a circuit, and the electrons surge out of the panel, ready to do useful work, powering a light, a phone, or an entire home. But there's one catch. The electricity a solar cell produces is direct current, or DC, a steady one-way flow. The appliances in your home, though, run on alternating current, AC. So the power first passes through a clever device called an inverter, which rapidly flips the current back and forth to convert it into the AC electricity that your lights and devices can actually use. A single cell only makes a little power, so dozens are wired together into a panel, and many panels are linked into a big array. From a tiny strip on a calculator, to the panels on your neighbor's roof, to enormous solar farms covering the desert, it's the very same trick repeated at every scale. Sunlight in, clean electricity out, with any extra power often flowing back into the grid. So a solar panel isn't magic after all. It's a beautifully simple idea. Sunlight knocks electrons loose, and a built-in electric field marshals them into a current, turning pure light into usable power with no fuel and nothing moving at all. As they quietly spread across the world, these silent sheets of silicon are helping reshape how we power our lives. And if there's a science or tech topic you want explored next, tell me in the comments. Your question could be the next video. If this made you a little more curious about the world, subscribe to the Binary Brew, and I'll see you in the next one.